Welcome to today's lesson over algebra of functions and composition. Let's look at number 2 and 4 and compare them. If you look closely, they are almost identical with the exception of one symbol, which is that plus sign. Number 2 is really quite simple. It is just addition. Number 4, though, is where we need to multiply this binomial times a binomial, in which you may be familiar with what is known as the FOIL method, F-O-I-L. F stands for multiplying the first terms, which would be 3x times 2x, which is 6x squared. O stands for the outside terms, which would be 3x times negative 1, which is a negative 3x. I stands for the inside terms, which would be the negative 4 times 2x, which is a negative 8x. And L would be the last term of each binomial, which is a negative 4 times a negative 1, which would be a positive 4. Now we would simplify this by combining the middle terms, resulting in 6x squared minus 11x plus 4. Let's also look at number 5. It's important on number 5 that you recognize that when you have a binomial squared, this is not equal to a squared plus 4. This would be wrong. We need to apply the method of FOIL to this binomial squared. This would result as an a plus 2 times an a plus 2. When we do FOIL, our first term is a squared, outside term is 2a, inside term is 2a, and last term is plus 4. When we combine the two middle terms, we get a squared plus 4a plus 4. So again, we have a middle term, which is why a squared plus 4 written above is incorrect. The right side would be to distribute this negative 4, meaning this would be a negative 4a minus 8. We can copy this down to the line that we are currently working on. And now combine like terms such that we have an a squared. The 4a's cancel out as 0 minus 4. Let's scroll down and look at number 4. This is referred to as a complex fraction because it has a fraction built into the larger fraction. In this case, let's focus on just the top or the numerator of this complex fraction. We have two terms. One is a fraction with a denominator of x minus 1, and the other is the number 3. The term 3 needs to become a fraction so that we can combine them under subtraction. So the number 3 needs a denominator of x minus 1. We cannot just create x minus 1 in the fraction. We must multiply by something equivalent to 1, which would be x minus 1 over x minus 1. This numerator would now be written as, and let's go ahead and multiply the 4 times the 2x. This would be 8x over x minus 1 minus 3 times x minus 1 over x minus 1. We will work similarly in the denominator, in which the 5 cannot be added to the fraction unless we get the denominator to be the same, which again is x minus 1. So we will take the 5 times x minus 1 over x minus 1, something equaling to 1, which will not alter the value of the 5. The denominator would then be 2x over x minus 1 plus 5 times x minus 1 over x minus 1. Now, the top of this complex fraction would be 8x, and distributing the minus 3 here would be minus 3x plus 3 all over that x minus 1. And the bottom of this complex fraction would be 2x plus 5x minus 5 over x minus 1. The top of this complex fraction can be simplified. 8x minus 3x is 5x. And I'm dividing by the bottom of the large fraction, which can also be simplified. The 2x plus 5x is 7x. And again, that denominator of x minus 1. When we divide fractions, we use the method of multiplying times the reciprocal of the second fraction. Often students refer to this as flipping the second fraction. At this point, we can reduce the x minus 1 over the x minus 1, resulting in 5x plus 3 over 7x minus 5. Sorry for having to pause the recording there for a minute. My allergies are bothering me and I had to cough and make a lot of racket. Let's scroll down and look at number 10. This really looks quite awful. However, it is not as bad as it appears. The focus again is on this binomial being squared. This is not x squared plus h squared. This is the application of our FOIL method because this is x plus h times x plus h. I'm going to go ahead and distribute the 2 and distribute the minus sign to the last trinomial. When I perform FOIL on the x plus h times x plus h, it becomes x squared plus hx plus hx plus h squared. Now I need to be careful combining like terms. My x squareds add out to be 0. My 2x's add to be 0. My 1's add to be 0. And therefore I have 2hx plus h squared plus h as the numerator. Now, often in these types of questions, you can factor and reduce, which we can do in this situation. The numerator can factor the common factor of h, leaving behind a 2x plus h plus 1. Now my h's divide out as a 1, and I get a result of 2x plus h plus 1. Now let's connect to college algebra. Part A, you simply need to subtract these two functions, your p of x and your r of x, being careful under subtraction that you subtract every term in r of x. This would result in x squared minus 2x minus x plus 4, or x squared minus 3x plus 4. Part C may be new to you. This symbol represents composition. This is not multiplication. This is composition. We would normally rewrite this as p of r of x. I tend to use square brackets instead of nested parentheses. P of r of x is simply p of, and we look and see what r of x is, x minus 4. At this point, the focus is on the function whose name is p. Now, everywhere there is an x in the function p of x, I will highlight it in a different color. I'm going to stamp over those orange x's with the new x minus 4. This result would then be x minus 4 squared minus 2 times x minus 4. Now the algebra here will require me again to do FOIL. This is x minus 4 times x minus 4, and I'm going to distribute the negative 2. X minus 4 times x minus 4 will be x squared minus 4x plus 16. Now I simply combine my like terms, and the result will be x squared minus 10x plus 24. Number 2 is focusing again on composition. They're asking two questions on number 2. One is F composition G of X, and the other is G composition F. And often these will result in two different answers. I will call this part A. So part A is asking F of G of X, and I must be careful with my symbol that it is an open circle representing composition. If it was filled, you would think to multiply, so be careful you use an open circle. So this can be written as F of G of X, which is F of, I go look for G of X and replace it with the expression x minus 1 over x plus 2. At this point, my function is the f of x function. So I go to the f of x function, and everywhere there is an x, I'm going to replace it with the expression in these square brackets. So this results in 2 times x minus 1 over x plus 2 with the minus 1 on the end. Now I simply need to algebraically clean this up. So this would be 2 over 1 times x minus 1 over x plus 2, which is 2x minus 2 over x plus 2. I cannot add these fractions unless the denominators are the same, so I'm going to multiply the 1 times x plus 2 over itself. The new denominator is now x plus 2, and the numerator is 2x minus 2 minus x minus 2. This results in x minus 4 over x plus 2. I will also compute G composition f of x, which we will call part B. And rewrite this as G of f of x. My first step is to go find f of x and place it in these square brackets. Now the focus is on the function whose name is g of x. So I go to the function whose name is g of x, and I take note of where the x variable is. I'm going to replace those x's with 2x minus 1. So this becomes 2x minus 1 over 2x minus 1 plus 2. To simplify this, it becomes 2x minus 2 over 2x plus 1. Number 3 looks a little intimidating, but if we take it step by step, I believe you will find it's not that difficult. We need to find f of x plus h. F of x plus h requires me to replace the x variable with x plus h. So this becomes 5 times x plus h minus 2, or 5x plus 5h minus 2. Now, this large fraction, the f of x plus h, we just determined to be 5x plus 5h minus 2. The f of x, which I will highlight in a different color, was given to me in the question to be 5x minus 2. Now to simplify this large fraction, I would have 5x plus 5h minus 2 minus 5x plus 2 all over h. When I simplify, this becomes 5h over h, which is 5. I hope this recording was helpful. Now go do your homework before you forget all that you just learned.